What the? Wherever you want, man. Oh yeah. Oh yeah. What the? All right. What? Cody? No Cody? Ethan? I'm like, this is like, I'm just horrible with names, but I'm really good with faces. So the fact that we're all wearing masks is gonna be really hard for me. But some of you, okay, just bear with me, because you're Ethan, right?
No.
I know. I just did. That was a joke. All right. Peyton. Peyton. M. Daddy. Ethan.
Yeah.
Corey. Corey's not here. Gavin. eBay. What up, eBay? You have the easiest name to remember now because of the whole eBay thing. Carter. Dre. Will. Caden. All right. If you ever see this attendance sheet and something's wrong, let me know. Okay. Well, that's it for today, guys. I'm just kidding. But I do have to go get your lab packets that I printed off, so I'll be right back.
Talk amongst yourselves. Stare at your phone. Front row seat. Well, they decided they weren't going to print. Cody.
All right. What are we doing? Whoa. Oh yeah. Oh yeah, look at that. Just look at it. Just look at it. Okay, so this is set up in components are in different places, but this is a lot like what you'll see. By the way, if you're sitting over here and that thing's blocking the screen, I'm on Zoom too, on that Zoom link, so I can record this. Or I can do something kind of crazy and take over your stuff. Would that be helpful if I did? There's only one person logged in. If you log in, I can take over your screen and put that right on the screen right in front of your face. But try it. And then if you say, hey, this is annoying, I can't check my email while you're talking, Zach, then tell me and I'll give you control of your screen back. Okay? So what did we cover last week? We went through the motor starter and the power circuit, right? And we did relays. That won't come up until later on in the labs, but hey, look at this lab one. What the? Oh, I guess that's right. Should go 1, 2, 3. So take lab 1, 2, 3, and then pass them around. So if this is lab 1, well, how do we need to wire this thing up? What's this part? Over here, this little dotted line part. It's a disconnect. Where's the disconnect over here? Top right. All right, let me what do you see now? Do you see this and not like a blue screen? Do you see this? What am I typing here? Smart ass. What does that say? Afbaft is ass and daddin? Good. Okay, so my disconnect. I think I told you what it was, but I didn't really show you. This one looks a little different because it's not fused. You need some more? Does this thing say out of paper right here?
Yes.
Oh, you picked a really bad seat to sit in.
Yeah, it is. What happens when you're late? Not a seat for the teacher.
You yank that. Yeah. So right now I'm not plugged in, but if I was, where on here would I get bit if I touch this thing? Top lugs, right? So this comes into the disconnect, and you'll see how all this works on yours. Yours is going to be a little bit different, but the principle is all the same. Typically, when you make up a disconnect, you put the line side on the top and the load side on the bottom. You guys know the difference between line and load side? Okay. Shit. Where'd my... It's a little drawing. I love this thing. Okay, you have a fuse here, right? There's a line side and a load side to everything in a circuit. Where's the load on this drawing? What is the load?
Motor.
The motor. That's what's actually consuming energy. That's what's using the power that we put into it. Okay, so there's your load. What the I used to love this thing. What the is going on? Doesn't want me to write over here. Anyway, all right. So in this fuse, the load side is the motor. The line side would be anything over here, but like the disconnect, the line side would be this. Anything that's coming from on the source side of a component is what I would call the line. And this is really starting to piss me off. What a joke. Seriously? Oh my gosh.
Could you just type into it?
I could, but then you don't get to see my beautiful artistic skills. See, and why is it doing that? All
You're right. You're a beautiful artist. It looks like a 5-year-old.
Thank you. I'm just a beautiful man. Wouldn't you agree?
Yes. And are you making a scene?
Yes. Yes. Right now I'm just drawing a cloud. Okay. Do you understand the difference between line and load now, right? So we can move on from my idiocy. Okay. I just want you to be sure as we start working, from here on out, when you're in the labs upstairs, you're going to be working with higher voltage. And on your disconnect, when you go through and wire up a lab, I have them locked out right now. Okay, so you'll finish up a lab, you'll tell me and I'll come look at it, and then we'll turn the disconnect on and run whatever you're trying to run, and then we'll shut the disconnect back off. So there shouldn't be any time that you're working on this thing, you got your screwdrivers on this stuff when anything's energized, right? Because this will be closed and the disconnect will be off, okay? But let's see if you can see those little, how far we got zoom, that's about it. Can you see these little knife blades in here, sort of? If you want to open your disconnect up and look at this, that's fine. But what happens is when I throw the disconnect on, these rotate and flip up and grab onto these top lugs, okay? And then make a connection between this lug and this lug. So these are the load side wires and they're going out to the field. They end up over here on these fuses, okay? So I'll just show you because I'm not plugged in. What happens when I flip that on, you'll see those little knife blades start to turn up, and then you can't really see it on the video, but you can see them. They go bloop. Okay, so that's your disconnect. On the inside of yours, you have 3 fuses, which are shown on your print. Okay. On yours and on mine, coming in with 208 volts. these go over to the line side of these fuses. You have a bunch of fuses there you get to work with. Okay, you see how they come over to the first set and then they jumper over to the next set? They're in sets of 3 because it's 3-phase. That's what we're working with. Everybody following me so far? So here's how I wire stuff up when I'm given a ladder diagram, and I recommend you do this too. I delete that arrow and then I delete this arrow. I recommend you do that. That was a joke. Are these wires made up going into the disconnect, line 1, 2, and 3? Yes, you won't even have to do that. Okay, this is the plug over here that goes into the cord. All right, so I'm doing this freaking thing. Okay, now from the disconnect going to the line side of these fuses, is that made up or do I have to do that? Nope, that's already done. Look at, can you see my cursor right here? Coming from the disconnect, I'm made up to these fuses, right? That's already done. Yours should be done, but walk through this print just the way I'm doing it so we don't miss any steps. There's a method to my madness. This is why I go through a print and I put check marks down. That's why I gave you a paper copy so you can take a pencil and put check marks down. Okay? And I always mark both ends of the wires that I should be having to make up. So yes, this one's done. That one's done. Make sense? Now coming from the load side of these fuses, I have to hit this little guy here. What's this? That's the starter. Where's my starter at? Oh, there's one. This little guy right here, right? Where's the line side of that? On the top. Looks like I'm already made up on the top. 1, 2, 3. These are coming out the load side of these fuses. Everybody see that? So on my print, that's done, and that's done. You notice on the print, there's this longer stretch of wire that goes from the disconnect to those fuses, right? And then there's a little shorter, little bitty short guy that goes down to the motor starter. But in reality, this is a shorter wire going from the disconnect to the fuse. This is a pretty long wire going all the way down this C channel over to the motor starter. So don't ever look at the ladder diagram and think, well, this wire should be shorter or this one should be longer. It's got nothing to do with where the components are at on the board or in any system. It just shows you physical connections of things. Right? Right, good. Okay. So I'm made up to the line side of the motor starter. What about the load side? There anything coming off of there? Nope. Where are they supposed to go? To the motor. But what about this little overload OL thing here? Correct. That's all part of the starter. So everything inside this little red box I'm about to draw, this is all on your motor starter. And it's already on there. Remember those little black things? The overload heaters themselves? Those are already bolted on to the motor starter. So I don't have to make that up. All I have to do is go from the starter to the motor. At some point in time, we're going to talk about how to hook these up. But right now, all of yours should be made up. We just have to hook up the 3 phases to the bottom of the motor starter. So I'll do that now. Let me find my stuff. Oh. Does it matter which ones I make up to what?
Probably, yes. Rotation.
In real life, yes, rotation. Who said that? Yep. So how do you reverse the direction of a 3-phase motor?
Switch 2 of the legs.
Any 2 of the legs, you can switch the rotation. And I'll explain that in just 1 second. But for this class, we don't really care what direction that motor spins, do we? All we're doing is turning it on. If we had a fan on there and the fan blades were, spun in a certain directions, we want to push air that way, then we'd have to check the rotation to see if it's rotating the right way. Okay. And then the last thing I need to do is ground this motor with something. Your grounds on your motor should already be made up. Do the best you can to make your wiring neat. This isn't going to be the neatest thing in the world, but it'll do. What did I do with my screwdriver? Come on, you guys are supposed to be taking care of me. So my motor is grounded. I'm hooked up to the motor starter. And lab 1, to me, is done. Because I got that done. So, if I fire up that disconnect, will the motor start spinning? No, it won't. Because these guys are open on the motor starter, right? I have to do something to close those. Do you remember what it is? Push what button? On here?
Yeah.
There's no button. Oh, this is a reset button.
Oh.
This resets the overloads if they're tripped. Right? So if the motor overheats, these will open up, killing the motor. Once the motor cools down, you hit that and it'll reset, making contact again.
Isn't there like a manual thing on the starter you can actually close it?
This one, no. There is on these relays. I don't know if that's what you're talking about.
Take power to the coil.
Correct. We need to energize that coil. I think what you might have been talking about is this, when I push that in, but don't ever do that in the lab unless I say it's okay. It's just not kosher. Does it work? Like the other day when I checked continuity across the contacts by pushing that in, you can do it. It can cause arcing and all sorts of stuff that we don't want. The way we close these contacts and make continuity between here and here is to energize the coil. Remember that? And what kind of voltage do we need? This is a 120 volt coil. Okay, so in order to close these on the print, we need to energize the coil with 120 volts. We don't even show that coil on this print, do we? We will in another lab or two. But first thing we need to do is create 120 volts somehow. We've got 3-phase 208 right now. So how do we create 120 volts out of that?
You should grab a leaf from somewhere.
Oh, because you got 120 on each leg?
Yeah.
Yeah. Yes, you could do that. We could actually pull the ground from the disconnect, but that's bad juju. We want our own 120 volt separate system for the bottom part of the ladder diagram, which is the control circuit. So what we're going to do is add a transformer. What am I doing? Oh. Whoop. So this is the symbol for a transformer. Okay. We need to pull off of 2 of these legs. I'm going to grab a control transformer. There's M Daddy. Here's a transformer. Similar to the ones you have, not the same model, but this one allows you to take a primary voltage of 240, 480, or 220, 440 on the high side. So this is the primary side. And out of it, on the load side, we get 120 or 110 volts, depending on where we hook it up. Okay, so all it is a big coil, right? Big inductor. It's using the principles of induction to knock that voltage down. That being said, if I put 120 volts into it from this side, could I get 480 out of this? Yep, it works both ways. But this is a control circuit transformer. It's designed to be a step down transformer. So on this one doesn't even have a diagram on it. Yes, it does. So dual wound connections for primary or secondary. Primary H for high, secondary X for slow. That was a joke. High voltage. So if we were bringing in 480, we would use this connection. We would connect 2 and 3 together, and we would bring our 480 into 1 and 4. If we were bringing in 208 or 240, we would connect 1 and 3 together and 2 and 4 together, and then we would hook up to 1 and 4. And then out of the secondary, we only have one option, so there's only two screws to land. You're getting 120 volts out there no matter what. Now, somebody talked about a neutral. We're going to make one of these things a neutral. Okay. So, that being said, on our print, we've got three-phase 208 coming in. Okay, so the voltage between any two of these phases is 120 or 208. If you took your meter from one of these things, let's say line 3 was 1 meter lead and the other meter lead you checked to ground, they would each get 120. So three-phase 208 is 120 to ground on each leg, 208 between them. So if we have 208 between lines 2 and 3, we take those down to a transformer through fuses 7 and 8, and we're going to hook up to H1 and H4 on the transformer. Okay, that's where we're bringing 208 in. On here, remember the line sides of these are all daisy chained, they're all hooked up together. All I have to do is grab 2 fuses here and take them over to my transformer, which are already done. Okay, so I'm in H1 and H4 of the line side of the transformer. So fuses in 7 and 8 are these ones. So that's done. And then I'm going to the transformer. Those are done. And X1 and X2, there's really nothing hooked up to them yet. Well, there are in real life, but on the lab, I'm done. Lab 3. Now we're going to actually start doing something with our control circuit. You see this guy here? What is that? That's the motor starter coil. So when we finally energize that thing, now we've got our 120 volts. When we energize that thing by pushing this button down, that motor's going to start spinning. So I want to show you guys push buttons first. Where'd my stuff go? Okay, inside of the junction box, it's got all the push buttons on it. Whoops. So that'd be this guy right here. You're welcome to open yours up and take a look at them if you want. But they're all made up. Every single button is made up with these wires coming to a terminal strip on yours. And you can use your multimeter to figure out what's what. I'll show you how to do that in a minute, but I want to show you how these guys work. So here's a normally open button, and actually you can use it either way, but I'll show you how they work. Zoom in. Everybody see that okay? Whoop. So there's different points of contact here where you can hook wires up, right? I want you to focus on these two being together. So these are terminals A, and these are terminals B. So if I wanted a normally open push button, which means those contacts don't make up right now until I push the button, I would use A. There's a little plunger inside of here that you'll see move when I push the button. That's what actually moves down and makes contact between those 2 points. See it? So when I push the button, it makes contact between these 2 screws. The flip side of that is these are normally closed. So I would have continuity between those 2 right now. If I put my meter on here, these 2, you'd hear a beep, and then I push the button and it opens up. So that's normally closed. These are normally open. And then I brought another one. This is a stop push button. You can see it's got the mushroom head stop on there. It's like an e-stop button. But all I have to do is change this out to a green one, and I can use it for start because it does the same thing, right? These are made up all the time by a spring pushing up on that contact. And if I push the button, it breaks these ones open and makes these 2. See how that works? So basically on my trainer, what I need to do is figure out what buttons go to what. And I've already sort of done that. But I want to walk you through. How are we looking? Here we go. So let's say for this start button right here, I want to use one of the green push buttons. And without opening this thing up, how do I figure out which one it is? Like that. Got your multimeter. And what setting do I need to have it on? All right, continuity. That's this guy right here. Little omega symbol, and then that little, this means like tone. So now that it's on and I'm on that setting, if I touch these 2 together, I'll hear a tone, right? So what I want to do is find 2 points on here that don't make a tone, but when I push the button, then they do make a tone, right? Ain't that one? There it is. These 2 right here. Can you see what I'm doing or no? There we go. So these 2 are the top push button. Top green push button. Okay, so these 2 points are what I want to use. Okie dokie. Now we can start wiring this thing up. So coming out of X1 on the transformer, I need to do this. I need to go find fuse 9. Where do you think that is? Yep. So you're going to have a fuse on the front of your transformer that is there just to protect that transformer. So out of X1, mine's already done. Out of X1, this little loop-de-loop wire here hitting the line side of the fuse. So I can mark that off on my print. The other side of the fuse goes down to my push button, right? So this guy, I need to take to one of those 2 points. So these two are my push button, correct? Yes? We keep losing the screwdriver. All right, now I need to talk to you about wire numbers. In your power circuit, where's the power circuit on the ladder? You got a power circuit and a control circuit.
Hours.
Yep, this is all your power circuit up here. That is going to be black wire. We're going to differentiate power versus control circuit with different colored wire. So all of your power circuit is going to be black. Everything down here on the load side of the transformer is going to be red. The wire numbering goes like this. Coming off the transformer, everything coming off of X1 is going to be a 1. You don't have to label this little jumper wire. You can put a 1 on there if you want. But coming out of this fuse is a 1. Okay, if I added another rung with a normally closed push button, let's say, and I went to a light, what would this wire number be? 1. Everything, let me put it this way. Wire number 1, when I energize one of them, they all energize. They all have to be connected. Okay, so any other place down here that I come off of this branch, everything over there would be a 1. Your neutral. So this is coming off X2 on the transformer. We're going to reference that to ground to make it a neutral. All of those are going to be white wires. You see the white wire coming off of my transformer? That's a 2. Everything over here on the load side of your loads is a 2. And you don't have to put the number 2 on those. We're going to use white wire for that. Okay. Otherwise, everybody would be constantly be running out of wire number 2. Using white for a neutral is just good practice anyway. All right. Now we have 1s and 2s established. Then it just goes top to bottom, left to right, like reading a book. So coming off of this start push button here, what is this wire number going to be? We're done with 1s. We're done with 2s. It's got to be a freaking 3. That's a 3, which makes this a 3. Coming off of this button, what's that going to be? Yep, you guessed it. That's a 4. What if I came off of here, went to another push button, and then to another light? this would be 4. It's on the same potential as all the other 4. So if this one gets lit up, this one gets lit up, and so does that one, right? What about going from this button to this light? This guy, that's a 5. That's how you do wire numbers. So to get full credit for your labs, obviously the first 2, you're not going to have any control circuit. So you don't need to put numbers up here. Okay. You don't need to number your power circuit. This is just for the control circuit or your red wires. To get full credit for the lab, you need to put wire numbers on everything. It seems time consuming. It seems painful, but you'll see later on when we get to more complicated wiring diagrams that the difference between lab 3 and 4 might be that you need to add another light down here, right? So all I got to do is go onto my mess of stuff over here and find a 5 somewhere, add a wire to it, and take it to the other light. Wire numbering is very, very, very important, okay? Do you all have wire numbers? They were supposed to be part of your tool list. If you don't have them, let me know and I'll get you some for today.
I don't know.
Okay. eBay, you don't have any? Okay, when we go in the back, I'll show you guys where some wire numbers are that you can use. Yeah, you can get them at Home Depot. Yeah, you can get, and if not, you can get them at Home Depot or Gray Bar, Menard, any supply house that sells electrical stuff should have wire numbers. All right, so I got 2s over here, 2, 3, 3. So I need to come off of this fuse F9 with a wire number 1 and go to the push button. That's what I just did, right? That's this guy. So I want to show you what these wire numbers are so you don't go through them too fast. They come in these little perforations, right? And I've already used up some ones, but you see how I've torn them in half? These are perforated in the middle for a reason. So unless you have a really big wire size, you can cut these in half. And all you do is take, like if it was a number 16, I put my fingernail right there where that is, that perforation, it should just rip. See that? But in order to be a good teacher, I'm going to go ahead and wire this because I got to be a good example for you guys. So what wire number is this? Going to my push button? It's a 1. Now, what do I need to do? Oh, I forgot my check marks. I got this done. I went through the fuse. That's that little bitty jumper. I went from the other side of the fuse down to my push button, and I got everything labeled. So I'm ready to move on to wire number 3. So where's that going to go?
The other wire.
Right. So the other side of the push button. What wire number is this? Number 3. So this is done. Bloop. And then where are we going with it? motor starter coil, which is here. Does it matter which screw we go to? Nope, we're going in and out of that coil. Doesn't matter which side we go to. What did I forget? Where'd my 3 go? Seems really boring and monotonous, right? But what if all of a sudden I wanted to say, okay, I want the other motor starter to run at the same time? All I know is I got to find a wire number 3 and run it over to this coil. Where's the wire number 3? Oh, look, I have one right here because I labeled it. Cool, right? Who's excited? Are you guys bored? Who's bored? Be honest. No, I love this stuff. This is good stuff. Okay, so almost done. This is done. Anything else I need to do? Yep. So the other side of this coil, I need to go to. Whoops! There's something missing on that print. Need to go to neutral. You guys are going to have to add this because I didn't put it in there. There should be something that looks like this. Oh. So you guys are gonna have to add that to your print because this is important. What is that thing doing? Actually, that's not even right. Yes, that is protecting the motor. That's the overload normally closed contact. So what happens on these is that those little heaters, like I showed you the other day, get hot and they open that circuit up, they open that contact. So that contact has to always be in series with the coil. Okay, so our number 2 wire needs to come from here to the overload contact, which is on this side of your motor over here. You may or may not already have a little jumper in there, but that's what this contact is for. So now I got this little white jumper on the other side of the coil going down to my overload, normally open relay or normally open contact. The other side, the line side, is, show you where that's going. Comes up this C channel and makes up. Why in the world is that there?
should be going over here.
Well, I've got some places on this terminal strip set up to be number 2 wires. Okay, so I'm gonna land it here and show you how it gets back to the transformer. You know, up on top of this terminal strip, let's zoom in. See those little tabs sticking out of the top? These guys, that connects all these terminals together, okay? So if I want any 2 or any neutral to come out of any of these other components, a light or anything else like that, all I have to do is land it on any one of these terminals, okay? I've already got this neutral going up to the lights. This one already goes back to the transformer, okay? And this little guy here is referenced to our ground. So that on your print is this guy. And I'll help you with that. If you don't understand that neutral and referencing it to ground, I'll help you with that when I come look at your setup. So that means that that's done, and we're back to the transformer, correct? So now if I fire it up and hit that push button, should start the motor, right? So what's the first thing I need to do? Right, nothing's gonna happen until I energize this, right? Now what? Should have 120 volts coming out of here, going to my control circuit, and if I push that button, it should energize this coil, pulling it in and spinning the motor, right? You guys are also like, suspense is killing me. Cool. All we're doing with this lab is energizing that coil, pulling it in and making the top and the bottom to let the motor spin. So that's labs 1 through 3. Good. Okay, let's go into the back. Yeah.
When the one neutral comes down to the end of the motor starter, it lands on the one. There it comes up.
This?
Yeah.
Neutral side of the motor starter. So on here, I put it here, right? Then it comes down to this normally open contact or closed. I'm sorry. If I said open, I'm sorry, but you see it even says NC down there. So from your neutral, you'll go to normally closed contact here. And then here, you'll go up to your neutral bar on your terminal strip or the transformer.
Okay.
So it just has to be in series with the coil. In other words, if this thing is open, that coil can never energize because this is in series with it. Got some extras? Thanks. Cool. All right, everybody got a lab packet? Let's go into the back. I'll show you a couple of things and you can start wiring.